Hello students, welcome back. Let us continue with important question from the chapter Carbon and its compounds. Here I am going to take the topic bonding in carbon, the covalent bond. This is the topic as given in NCERT. Now here we have two portions. One that talks about the formation of covalent bond. That means why carbon forms covalent bond. We're going to talk about that formation of covalent bond. The second one is about the representation of covalent bond. You're going to represent the covalent bond, I'm going to use the short form CP, by Lewis dot structure, also called as electronic dot structure. Now this topic called as electronic dot structure is very important, and we are expecting a question from here. It could be a direct question simply asking you to draw the electronic dot structure of a particular molecule, or it might be a clubbed question where they might ask you, like for example, write down the lower homologue and draw its electronic dot structure. I'm going to take it in part 3B of the video. So in my opinion, we can expect a question from this topic, bonding in carbon, the covalent bond, and probably the question will be about electronic dot structure, or a reasoning question which I'm going to take up in this particular video. So I'm going to mark this topic as very important, right? So let's move on to the question that can be asked from formation of covalent bond. So the first question is, why carbon cannot form ionic bonds? Or if I have to rephrase the question, it can be asked in another manner, why carbon cannot form bonds by losing or gaining electrons? Now, my dear learners, you've studied about ionic bonds in the chapter metal and non-metals, that is chapter number 3, which was a part of term 1 syllabus. There you have learned bonds are formed between a metal and non-metal by losing as well as gaining of electron, where the metal loses electron and the non-metal gains electron, and the bond or the force of attraction between them is called as electrostatic force of attraction, and the resultant bond is called as ionic bonds. So here it has been asked, why carbon cannot do the same? Why can't it form bond by losing or gaining electrons? Now this is the answer that you're supposed to write in your board examination, and this is provided in NCERT textbook. So this is what you're supposed to cram or learn, but if in case you understand, you'll be able to put it in your own words. Now let's take up what happens if carbon can lose or gain electrons, right? So carbon has a configuration of 2, 4. Now you all know that atoms react in order to complete either their duplet, that means 2 electron in their valence shell, or octet, 8 electron in their valence shell, so that they get a configuration similar to that of noble gases or inert gases, and thus are stable. Now we'll talk about the valence shell. So the valence shell is this one, that's L. Carbon has 4 valence electron. So there are 2 possibilities, right? Number 1, it takes 4 electron. Why? Because it wants to complete its octet. Now if carbon takes 4 electrons, right, what happens? So carbon will have a configuration of 2, 8, that is similar to that of neon, and it will be stable. We have to see why this is not possible. Alright, now let's take this case. We have carbon. I'm only going to show the protons just right here. Number of protons equal to 6. Only the valence electron I'm going to show, that is valence shell. So we have 4 electrons here. If 4 more electrons have to enter, that means if carbon has to take 4 more electrons, what will happen? This is the shell, the L shell. These electrons will try to come here. Fine. All of them will try to come here. Now initially 6 protons were holding a total of 6 electrons. Now the same number or same amount of positive charge has to hold 4 more additional electrons, that is 10 electrons. So the hold of proton on the electrons is not going to be very strong, because I told you positive is going to attract negative. So these electrons are held by positively charged nucleus, that is the positive charge of protons. Now the same number of protons have to hold greater number of electrons. That is very difficult. Also one more reason is there, which is not given in NCERT, that when electrons are going to come here, these are all electrons, right? Now when additional electrons are going to come inside the same shell, these electrons and these electrons are going to repel. because negative charges repel. Right? They're similar charges. This is having a negative charge. This is having a negative charge. They will not let this electron to come in easily. Now, whatever I said, so you're not supposed to explain that in too much of detail. It will be hardly 1 mark question. You're supposed to write, if carbon could gain 4 electrons, now it would form a C4 negative anion. What does that mean? Something is gaining 4 electrons. First, number of protons were equal to number of electrons. Now, the number of protons are less than number of electrons. Negative charge is dominating. How much? 4. So, carbon, which was neutral, will now form C4 negative. Why 4 negative? Because it has gained 4 electrons, and electrons carry negative charge. So, when 4 electrons will be added up, carbon will form an ion which carries a negative charge, and a negative charge ion is called as an anion. Right? So the first line says, if carbon could gain 4 electrons, it would form a C4 negative anion. But in this case, it would be difficult for 6 protons to hold on to 10 electrons. So 6 protons are going to hold 10 electrons, which is going to be fairly difficult. Moreover, to overcome inter-electronic repulsion, now this part is not given in NCERT. Even if you miss it, CBSE will not deduct marks because they're going to do the correction as per NCERT, strictly as per NCERT. So you'll get marks. Huge amount of energy would be required, and thus it is not possible. So if you want, you can skip this. Now let's take up the other case. If carbon could lose 4 electrons, now carbon, again the configuration is 2, 4. If this carbon loses 4 electrons, why we are saying 4 electrons? If this scenario happens, carbon is going to have 2 electrons in its outermost shell now, because all 4 electrons have gone, they've lost, and now its duplet will be complete and it will have configuration similar to that of helium, the inert gas helium. Now even this is not possible, and let us find out why. Well, if carbon loses 4 electrons, so can I say number of protons will now be greater than number of electrons? And how many electrons it has lost? 4. So protons carry positive charge. So we'll have carbon which bears a 4 positive charge. Now it is a cation. Positively charged ion is called as cation. Well, this is not feasible. Let's see why. Protons 6, right? And you have how many electrons? 2 here and 4 in the outermost shell. Now knock out these 4 electrons. So you have 6 protons holding on to just now 2 electrons. Now look, initially 6 protons were holding on to 6 electrons. Fine. Thereafter, 6 proton, 1 electron we are knocking off. It's going to hold 5 electrons. So won't this positive charge hold on to this electrons a little more tighter as compared to this case number 1? Because here 6 protons were holding 6 electrons. But now the number of protons remains same after knocking 1 electron, and the number of electrons have reduced by 1. So it's going to hold it more tightly. Let's say we knock out 1 more electron. So 2 electrons down. Now it's going to hold on to 4 electrons. It's not going to let it go. Again knock out 1 more. So we have 3 electrons. Now these protons are going to hold on to these electrons very, very strongly. You cannot pull out the electrons easily. If you want to, you have to supply energy. And that energy is quite huge, which is generally not available. And finally, what will happen? 6 protons after loss of 4 electrons are going to hold on to just 2 electrons. So this step down, just knocking out electrons and protons holding on to less number of electrons. They are going to hold it very strongly, and to remove the electrons further in every step, you require enormous amount of energy which is not available, and therefore carbon cannot lose 4 electrons. Thus, carbon can neither form bond by losing electrons or by gaining electrons, right? So the only mode by which it is going to form bonds or by which it is going to complete its octet is going to be sharing. And such bonds formed by sharing of electrons or sharing of valence electrons are known as covalent bonds. So let's talk about the answer. You know the first part. Coming on to the second part. If carbon could lose 4 electrons, what will happen? It would form a C4 positive cation. Here again, it would require a large amount of energy to remove 4 electrons subsequently. Okay, 1 electron, then 2, then 3, then 4, and thus it is not possible. So if in case you have this question in your examination, this is the answer. right? You do not have to give this explanation. This is not required. Let's move on to the next question. The next question is, this has been a sample question in the year 2021, right? With a valency of 4, how is carbon able to attain noble gas configuration in its compounds, right? Or how carbon completes its octet? I've just told you the answer is simply by sharing of electrons and thus forming covalent bonds. What does it mean by valency of 4? You know, carbon is a nonmetal with an electronic configuration of 2, 4. So to calculate its valency, it's 8 minus of 4, 8 minus valence electron. So we have a valency of 4. In order to complete its octet and thus attain noble gas configuration, it is going to share electrons. How it is going to do that? Formation of covalent bonds. So this is the question. This is a 1-mark question and your answer is just this. Let me give you an example also. Example, methane molecules. For those students who have not been able to understand, they can quickly understand this concept by this example, methane. I've only shown valence electrons because in bond formation, only the outermost electron participate. Remember that. Fine. Whenever there's a bond formation, you are going to have this outermost electron that are going to participate, also called as valence electron. So you have carbon here, 1, 2, 3, 4, 4 valence electrons. It requires 4 more electrons. This is hydrogen. Hydrogen has an electronic configuration of 1. Carbon 2, 4. It requires 4 more electrons. It requires only 1 electron. Here the duplet will be complete. If it gets 1 more electron, its configuration will be similar to helium. Its duplet will be complete. Here, if carbon can get 4 more electrons, its octet will be complete and its configuration will be similar to the nearest noble gas, neon. Right? How does it do? This is the electron of hydrogen. It is going to share 1 electron. The sharing has to be mutual and equal. If I am giving you 1 electron, you are supposed to give me 1, right? And the shared pair of electrons belongs to both of them equally. But this carbon's octet is not complete. It is just having 2, 5 configuration. So we'll have 3 more hydrogens. 3 plus 1. Fine. So total of 4 hydrogens. So 1 I've shown here, the second is here, the third is here, and the fourth is here. So you see now 1, 2, 3, 4, 5, 6, 7, 8. Carbon's octet is complete and every hydrogen's duplet is complete. And the bond that is formed by sharing of electron, this mutual bond, C, 1 here with this hydrogen, 1 with this hydrogen, 1 with this, 1 with this. So it's going to have 4 covalent bonds. So there could be a question, how many covalent bonds are there in methane? So first you will be able to draw the structure, which I'm going to show in the next video, and then count 1 covalent bond, 2, 3 and 4. So methane has 4 covalent bonds, single covalent bond. So for formation of covalent bond, these are the 2 questions that may be asked. In my next video, I'm going to talk about drawing of Lewis structures or electron dot structures. It is a very, very important topic. So keep watching and I see you in the next video.